I told my husband if I have to go to school, I'm going to do math. Okay, so not only do we have to do math today, we get to do probably the equivalent of going to the dentist in math class today. Which, I normally hate going to the dentist, but, you know, you learn that when you get to be an adult, it's actually kind of nice because sometimes it gets you out of work. And then sometimes they put you to sleep, and that's nice. So going to the dentist is not necessarily always bad.
If it's your wisdom teeth getting pulled out, they can rub you.
Okay, so, yeah. So we're going to the dentist today. Oh, not even with the math workshops. When we start the notes, that's when we'll be going to the dentist. But it's going to be okay. We're going to get through the dentist as quickly as possible. So let me remind you, we've already done chapters 1 through 4. When we left, we were on chapter 5. We did one section and we took a test on it. And I'll remind you about that one section in just a second. So we're on chapter 5 if any of you still have textbooks. If you ask me, I've only got one unpacked at the moment, but I can find more if I need to. Okay, so we're on chapter 5. And I know there is a quiz coming up one day next week, which I know you don't want to hear because you just got your toe back in this room. But just heads up, tests are still happening, all the things. Okay, so your first math workshop problem has a typo. It's supposed to be A's. Problems don't always have to be X's. It's supposed to be A's. What's the first thing I'm supposed to do in this problem in order to factor? I need to get everybody on one side. So what do I need to do? 6, get the point. So a squared plus 14a plus 48 equals 0. This is a nice factor. Why is this a nice factor? Why is it a nice factor? It does not have a GCF, although 14 and 48 do. Because there's 1 in front, no. Tell me about the leading coefficient. The leading coefficient is 1, so that's why it's going to be an easy factor. So I need two things that add to 14 and multiply to 48. 7 and 2, 7 times 2 does multiply to 14, or 7 plus 7 does add to 14, but 7 times 7 is 49. That was close. Something else multiplies to 48. 8 and 5 multiply to 40. Yes, thank you, Reagan. You can get the point. Okay, so Reagan gets the point because 6 plus 8 is 14. 6 times 8 is 48. So it should be A plus 6 and A plus 8. Okay, it says we're supposed to factor completely, and since there's that equal to symbol, I know I'm actually supposed to reach two concrete answers. So I'm going to do A plus 6 equals 0, and A plus 8 equals 0, and I end up getting what two numbers? Okay, and 6 gets another point. So we jump back to school and Miss Thompson's already wanting to factor. Yay, fun times. Okay, I'm going to skip number 2 for the moment. Why am I going to skip number 2 at this moment? One said it first. He said leading coefficient. So the leading coefficient is a 2, and that's going to be a problem. When you would say on number 3, Miss Compton, the leading coefficient is a 7. That's even worse. But something else happens on number 3. Can someone tell me something special about number 3? Alex, you were trying to do it, say it earlier. We worked on this one. There is a GCF. What is the GCF? X. Okay, so 2 and 6 get a point. If we factor out an X, because everybody has an X, we would be left with 7x minus 4. We're going to set that equal to 0. This is a side note. It just popped in my head. We are going to swap groups. I don't know when things are going to happen. No, it's not. It's going to be either, well, it's either going to be at the end of the chapter 5 test, or it's going to be when we finally get this show on the road and go see a new room anyway, so it's going to be a whole new setup and all the things. So it depends on which comes first, the chicken or the egg. So either it's the chapter 5 test, or it's going to be when we move. I don't know. Okay, so I know one of my answers is x equals 0. I'll give a point to someone who knows my other answer for number 3. Yeah, 6 gets the point. So we're going to set each factor equal to 0. So I set x equals 0. I set 7x minus 4 equal to 0. So if I add 4 to both sides, I'll have 7x equals 4. I divide by 7, I get x equals 4 sevenths. So the answer on number 3 is 0 and 4 sevenths. Why are we having 2 answers? What kind of problems are we dealing with? Why do we have 2 answers? Not always. If I had 3x equals 0, you would say x equals 0, and that problem only had 1 answer. Why does my problem have 2 answers? Okay, 3. Because this squared, it's a quadratic. Quadratics have either 0, 1, or 2 answers. Okay, number 2, let's go back to it. It's a hard factor. I like to do guess and check. What's the name of the method Miss Brister likes? I heard pieces of it. We'll give Brister's table the point. It's slide, divide, bottoms up. Most people forget the bottoms up. I don't do it that way. Okay. And I know it's me, and I know you're not chattier than usual, and I know that you're mad that it's the first day back, and I totally get it, but I swear to you, the pregnancy hormones will keep going on you anytime soon. So if I were you, I'd chill out with the talking in between, because I can't even control myself at this moment. I try. Okay, so I like guess and check because I think people forget to do bottoms up on slide, divide, bottoms up. But if you want to solve this a different way, you can. I'm sure she's going to. Okay, so I know it's 2a and a because 2a times a is 2a squared. I don't really have any options on that. What I'm going to guess is what numbers go here. So I can do 2 and 5. I can do 1 and 10. I have a couple options. I don't know. I like the 2 and 5.
Which side would they both be on? Would they be on?
Well, I was thinking about doing the 2 here and the 5 here because I knew 2 times 2 is 4 and 4 and 5 is 1. I'm thinking, I don't know. I'm guessing. Okay, so I'll say you're the positive, you're the negative. Literally just guessing. Okay, so if this doesn't work out for me, then I can go back and change the signs of the 5 and the 2. Or I could go back and go with Seth's suggestion of changing it to 1 and 10 to begin with. But I don't know. I'm going to check. What method do I use to check? How do I check it? What is that called? Foiling. Okay, I heard it from 2 groups. If you're those 2 groups, you would still point. Okay, so if I FOIL, I've got 2a squared minus 4a plus 5a minus 10 equals 0. If I combine my like terms, I've got 2a squared plus a minus 10 equals 0. What does that mean?
No.
That means I guessed correctly because this matches the beginning. So this is correct, but sadly Miss Compton used up all her room guessing down here and checking it out. She didn't actually find the 2 solutions. So I still need to find the 2 solutions. So I've got to set 2a plus 5 equal to 0. And I've got to set a minus 2 equal to 0. Because I did guess those, and they were correct. So now to find the actual solutions, I set each term equal to 0. So I'll get a equals 2, and what is the other number?
A equals negative 5 over 2.
Yes. 2 gets the point. Okay, so I know you haven't had to factor in weeks, and I'm certainly wanting you to factor, but in case you can't notice with 4 through 7, factoring is here again, back in our math workshops. It means it's going to make the next math workshop test again. Meaning if you thought you could just block that out, you cannot. Okay, I handed you a packet. Have that out. But also, how about that cute little handout you picked up on your way in? It has a typo we need to fix, but otherwise, it is a useful thing. Okay, so Addie. So when we last were doing math, we were in section 5.1. You don't have to write any of this down. I just need you to listen. When we were last doing math, we were doing 5.1. And in 5.1, we were talking about adding, subtracting, and multiplying with polynomials. So we might have to add like 3a squared plus 9 plus 2a squared minus 3. And we would combine our like terms, and you were like, oh, okay, so that's 5a squared plus 6. It was no big deal. Adding was fine, and you liked it, and you did well when you added things. Let's do the same problem but subtract it. Subtracting was fine. You would have said 3a squared minus 2a squared. Well, that's just a squared. 9 minus a negative 3, so it's just 9 plus 3, which is just 12. I'm making them up. Okay, so you were good at these, with one exception. You were good at these, except sometimes you tried to make everything into multiplying. Sometimes you ignored the plus sign, you ignored the minus sign, and you just assumed on every single problem in life that you were supposed to FOIL. And that's just not the case. So as a reminder, if there's a sign in between, obey the sign. If there's no sign, then yes, you can assume it's multiplication and we could FOIL it out. And you're good at FOILing, so 6, a to the 4th, and I could keep going if I needed to, but I'm assuming us in FOILing are good now. So you can add, you can subtract, you can multiply polynomials. And then someone says, well, hey, can you divide polynomials? And that's when life gets crazy. So that's what this new section is, of what if we wanted to divide. Okay, so look at your packet. We're going to start off with an easy one. Number 1 on the very front page of the packet. It says simplify this. So we're wanting to divide this top polynomial in the numerator by 3xy, the polynomial in the denominator. Now that sounds kind of complicated, except for the fact that in our numerator, Alex is on a roll today and he didn't even know it, in our numerator we have a GCF. Yeah, there's an X. What else does everyone in the numerator have in common? I heard it. Okay, 6. It was 5. Was that you, 5? Okay, if it was, then here's the point. If not, and you lie, then you know what's going to happen. Okay. 2x to the third, y to the third. So literally, I'm going through the numerator. If I pull out a 3x, I would be left with 2x to the third, y to the third. If I pull out a 3x, I'm left with a 4x squared, y squared. If I pull out a 3x, I'm left with a 6x. Okay, so I'm going to credit, I know Alon didn't help, but I'm going to credit Hunter with this. So Hunter noticed that everybody in the numerator had a 3x that could be factored out. So he pulled a 3x out of the first term, the second term, and the last term, and this is what he was left with. He noticed now, hey, I've got a 3x in the numerator and a 3x in the denominator, and he would probably cancel them out, and that's fine. We can make this problem a whole lot nicer if we went back to the beginning and added in a y, which is what I meant to do to begin with. Because then Hunter would be wrong. Our GCF would not be 3x, would it? What would our GCF be? 3xy. 3xy. So let's add in a y, and literally Ms. Compton's just trying to make our lives a little easier. So all we're going to do is decrease our exponent on our y. So it was y to the third, now it's just y squared. It was y squared, now it's just y. Okay, and I purposely did this because now what do we have in both the numerator and the denominator? We do. We have 3xy and 3xy, and so they'll cancel out, and literally our answer is the thing in blue in the parentheses. That's our answer. We're done. So we've not actually divided really anything. All we did was pull out a GCF, and it just so happened that the GCF we pulled out matched the denominator, and so we canceled them out. So that would make life nice if only we could always make the numerator and denominator cancel out. Let's see if it works out on number 2, but clearly it's not always going to work out in life, so we've got to have a backup plan. Are there any questions about number 1? I know, math on Thursday. Woo. Okay, and then number 2 happens. Number 2, it doesn't even look like a division problem. I don't see the division symbol. It looks like a multiplication problem, except for there is an exponent thing going on. What about the exponents let me know it really was a division problem? 6, get another point. Do you see this -1 with that second term? Aren't we supposed to punish it and put it in the denominator because of that -1? So shouldn't 4c squared d squared go to the denominator? That's why we covered rules of exponents recently. There is a GCF in the numerator. What is the GCF? There's a 4 and then what else?
8. There's also
Oh, there's an 8.
yeah, there's an 8. Yeah, 8C2D2.
He's right. He's right. It's an 8. Now, you and I both know that I'm going to pretend like he never said it was an 8. He's right, and I know in life you're supposed to pick out the biggest GCF, and I know all the things. But aren't we trying to make it cancel with the denominator? And then there are 4 in the denominator. So even though I heard Arturo, I'm going to ignore Arturo, and I'm only going to pull out a 4.
A great way to kill them.
Okay, so if I only pull out a 4, what would I be left with? 4 what? C what? And then D to the what?
D to the 3rd.
And then what? -6, and then what?
That's about it.
Because 2 plus 3 is 5. Add your exponents and multiply.
That's just 6.
And that's just it. Okay, so let's go back over this. I pulled out a 4. 4 times 4 is 16. C squared times C squared. You add the exponents, you get C to the 4. D2, D3, add the exponents, you get D to the 5th. And then 4 times -6, I get -24 C squared D squared. I already have the C squared D squared, so it literally is just -6. Okay, but life works out nicely again. They cancel out, and my answer is literally 4c squared d to the 3rd minus 6, the part that was in parentheses. That's my answer. Now again, how lovely it is that for our first 2 problems, we were able to pull out a GCF, and just so magically happened that that GCF we pulled out matched what was in the denominator. So we said, hey, since those match, let's cancel and call it a day. Isn't that lovely? Do you know how rarely that happens in life? A math teacher must have picked that problem for us to make it happen. That does not happen often. Instead, what we normally have to do for a division problem is something called long division, which should sound familiar because long division is something you did in elementary school. Okay, so I gave you a cute little handout. Take it out now. It says polynomial long division. Okay, I'm going to work the problem they did. They did 7 going into 1, 2, 3, 4. Now, this is the kind of long division you're used to. It's been a long time since someone's dared to ask you that. You normally just type it in your calculator and give me the decimal. It's been a long time since someone's asked you to use a house and do this out. But you did learn that at some point. And so we're about to take the concept of this and apply it to polynomials. So apply it when there are x's and y's and other things involved. Okay, so we used to say, okay, 7 can't go into 1, but 7 can go into 12. How many times can 7 go into 12? Okay, it goes in 1 time. So we would put a 7 down here, and then what would happen? Okay, you would subtract it, and you would get 12 minus 7 is 5. But 7 doesn't go into 5, so what do I do next? You would bring down the 3, and you would say, how many times does 7 go into 53? 7 times, he said? Maybe. So 7 times 7 is 49. Okay, but then what? We got to subtract it. What do you get when you subtract it? You get 4. And then 7 doesn't go into 4, so he told me to bring down the 4. And then 7 times 6 is 42. Okay, but now I'm left with a 2. 7 doesn't go into 2. It's a remainder of 2. Okay, so there is a tiny typo on your cute little sheet because I just did the exact problem in the top left corner. It's supposed to be 1, 7. That 6 is in the wrong spot. Cross out where the 6 is, put it 176. The answer should be 176, and then 2 7s. Okay, we did all this. We got down here to the end, and it's safe because we had a remainder. And when you have a remainder, you put the remainder over what you were dividing by. So we did 2 divided by 7, so 2 7s. That was a remainder. We like to not have remainders, but let's face it, we have lots of remainders in life. Rarely, rarely does life work out perfectly for us. So we're going to use that same sort of concept to do long division. Now, I'm going to work 3 and 4 on your notes packet, but I'm giving you this handout to keep for life. And I am going to let you hold on to it for the next little while. So if you get confused, I swear this little handout explains what I'm about to explain over and over again. So if Mia wants to read this later, that would be very helpful for her. I'm telling her it's a useful handout. I would keep it out for a while. Okay, so we're going to do the same thing. We're still going to do that same sort of draw a house long division. But instead of just having like 7 into 1, 2, 3, 4, we're going to have x minus 5 into x squared plus 3x minus 40. I still draw a house. I'm still going to think it through about the same way. I'm still going to follow a similar, very similar pattern. But I'm going to say this divided into that. Now, so I got to first things first. I got to think, how can I make that x into an x squared? X times what will give me x squared? Isn't x times x squared? So x times x is x squared. The way in our other problem, we were trying to think through how to get to 12. You know, the closest we could get 7 and 12. Right now I'm thinking, what's the closest I can get x to that x squared? But, okay, so I did x times x and I got x squared. But what about the 5? The negative 5. Doesn't he need to get multiplied too? So I did x times x and I got x squared, but I also need to do negative 5 times x and get negative 5x. Are there any questions about the green? Okay, well, we need those x squareds to go away, right? The whole point of this is to make life simpler, so the x squareds need to go away. So we need to subtract this. So x squared minus x squared, those do cancel out. The x squareds go away. But I have 3x and a minus a negative 5x, so I actually end up with how many x? 8x. And so I like to put mine in parentheses, because you can see how sign errors can happen really easily in long division problems. Really easily. So I like to put parentheses and put my minus outside the whole thing so I can think through x squared minus x squared. Yes, those cancel out. 3 minus negative 5 is really 3 plus 5, which is 8. Okay, well, yay, we got an 8x. But, I mean, so x times what will give me 8x? What can I do? I just got to multiply times 8. You make it life too hard. So if I multiply x times 8, I'll get 8x. But heck, I have to do negative 5 times 8. What's negative 5 times 8? Oh no, he doesn't have a match. What did I not do that I should have done that I
Brought
normally
down
do?
to negative 40.
Yes, just like you did in long division in elementary school. You bring down things to combine with other things so we can bring down that negative 40. Okay, but again, we're wanting those 8x's to cancel out, right? Wasn't that the whole point? So I'm going to subtract this whole line. So 8x minus 8x is 0. And I have negative 40 minus negative 40, and what does that end up giving me?
Positive 40, which that gives us 0.
Yes, so it's negative 40 plus 40, which ends up giving us 0 as well. So do we have a remainder in this problem? No. So literally, you're like, Miss Compton, we did all that to realize this. Yeah, literally the answer is x plus 8. So we could have, from the beginning, x minus 5, x plus 8. I can check it. When I FOIL it out, x squared plus 8x minus 5x minus 40. Yeah, that's x squared plus 3x minus 40. So it was actually a really easy problem that we turned into something complicated. But I mean, we have to practice the easy ones to understand the process. Clearly on the next one we're going to have a remainder. We need to practice one with no remainder so we can prove it to ourselves that we're not crazy. And the next one we're going to have a small remainder. And anything that's a remainder, so we normally would put it over the number outside the house, we're still going to do the same thing now. So let's say Paige, and she didn't mess up, but let's say Paige had 2 left. Well, then she would have 2 over x minus 5. Whatever her remainder is, she's going to put it over whatever that thing was she was dividing by. Okay, are there any major problems with this problem? We're going to do one more, and if you bear with me and help me with it, I swear to goodness I will not say anything about homework or anything for today. Okay, one more. Okay, so let's draw a house. What should I put outside the house? Okay, if your group said 2x plus 1, give yourself a point. Underneath the house, I'm going to put the rest. Oh, and I'm going to stop right there for a second before I write it in pen. Woo! Dangerous times, dangerous times, dangerous times. Miss Compton almost made a fatal mistake. Woo! What is weird about this? What's missing? Six, get another point. Notice how there's no x to the thirds. There's an x to the fourth, there's an x to the second, there's an x to the first, but there's no x to the thirds. We're going to need that, so we're going to write in a 0. So it was 8x to the fourth. If you need to write this down, you can. 0x to the third minus 4x squared. We're going to add in a 0x to the third. Why? Because we noticed he was missing. And he's going to come up because I promise you, you're like, I tried it earlier. I was like, I'm not going to write down a 0x to the third. I'm going to let it go. Be like, Elsa, it didn't work. I eventually had to go back and fix it. So if somebody's missing, you do have to put in 0x, or 0x to the fifth or fourth or whatever's missing. So we had a third missing. I know. We had an x to the third missing, so I put in a 0 for that. I got excited there. Okay. So I want to know how to get from 2x to 8x to the 4th. So 2x times what will give me 8x to the 4th? I know it's 4, because 2 times 4 is 8. But it's 4x to the what power? Yes, because x times x to the third gives me x to the 4th. Does everyone understand how Hunter came up with the 4x to the third? Okay, he understood 2 times 4 was 8. He also understood x to the 1 plus x to the 3 gave him x to the 4. Okay, but not only did he multiply the 2x times that, he has to multiply the 1 times the green. So 1 times 4x to the third, he's going to get 4x to the third. And now all of a sudden he's really excited he wrote that 0 down. Because notice, we have somebody with x to the third, and if we hadn't written that 0 down, we would be in so much trouble right now. Now, we want those 8x to the 4th to die, so we're going to subtract that whole second line. 8 minus 8 cancels out. 0 minus 4x to the third, I end up with
Negative 4x to the third.
negative 4x to the third. Now, again, I like to put my parentheses and think it through slowly. Because if Dontarius gets in a hurry, he's going to make a sign error here, and then everything else is going to be messed up from then on out, and it just stinks. Now, he's going to get a lot of pity points for having it set up and thinking it through and following through, but it sure would be nice to just have the right answer. Okay, so he asked himself, how do I go from 2x to negative 4x to the third? Well, clearly I need to multiply by negative 2x squared, and I would get negative 4x to the third. 1 times negative 2x squared, I get negative 2x squared. And I got to bring that bad boy down. And oh no,
Then find by a negative.
I got to subtract that second line so those x people cancel out. Negative 4x plus 4x to the third, they do cancel out. But then I have negative 4x squared plus 2x squared. I end up with negative 2x squared. Okay, we will come back to this problem tomorrow. Go ahead and pack it on up now, that's fine. I'll let it go like also. Today and tomorrow, I'm going to baby, well today I already did, but tomorrow I'm going to still baby you through it. On Monday, we have a round the room thing for you to practice.